Okay, so today we're going to learn about the concept of a mole. All right, and a mole, this is probably one of the most important concepts that we'll learn this year in chemistry. And we'll talk about why. So most of the time when you guys hear mole, there's probably a couple things you think of. You know, you might think of the furry little animal of a mole. You might think of like moles on people's skin, or you might think of like maybe a spy, a mole within an organization. Okay? Of course, none of those moles are what we are going to use in chemistry when we say the word mole. Okay, a mole is very close to the idea of a dozen. Okay, so when I say a dozen, all your minds automatically think 12. Okay, so we have this idea, hey, a term equals a set number of value. Or if I say pair, you think of 2. If I say like a ream, if you have a ream of paper, you'll be dealing with 500 sheets of paper. If you have a gross, you have 144 items. Okay, so a mole is like this. A mole is a unit of measurement. Okay, so and that's what we're going to learn about in chemistry and how we're going to use it in chemistry. So a mole is a unit of measurement. Okay, so it's a unit is really what we want to know about. All right, let's take a look about why we even introduce this weird concept as a mole. Oh, and mole sometimes is also abbreviated MOL. Okay, so MOLE is equal to MOL. It saves you hours of work to drop off that E when you're writing it. Okay, so we go down here and look at this reaction here. So what we have here is this is how water is synthesized, or this is how water is made. So we have different types of atoms. We've got hydrogens, we've got oxygens, and they form water. So we have 2 molecules of hydrogen plus 1 molecule of oxygen that has 2 atoms in here. And when that reacts, it goes to 2 molecules of water. And each molecule of water have 1 oxygen atom and 2 hydrogen atoms, so H2O. Okay. So all water is H2O. All water has these 2 hydrogens and 1 oxygen. So here's at the most basic level, this is how a reaction happens. It happens because we're counting how many atoms of this I have, how many atoms of this I have, will produce how many atoms or molecules of the products that I get. The problem is that when we see a chemical reaction, we're obviously not seeing it on the atomic level, right? Because atoms are so very small. Okay? So, but we need a way to count these atoms in order to know how many atoms I have. And that's where the concept of a mole comes in. And so since atoms are so small, a mole, we can't say, hey, dozens of atoms. Okay, we can't talk about dozens or reams or anything like that. We need to talk about a massive amount of atoms. So what a mole is, 1 mole, okay, a mole, is equal to 6.022 times 10 to the 23rd items. So since it's a unit, just like a dozen, you can have a dozen of anything. Maybe I have a dozen shoes, I have a dozen students, I have a dozen pens. You can have a dozen of anything. Technically, you could have a dozen or a mole of anything. And when you have a mole of something, what you're saying is you have 6.022 times 10 to the 23rd items. Okay? So if I write that out not in scientific notation, it would be 60. I think that's right, if I count my zeros correctly. So that's how many items 1 mole of a substance is. And remember, the reason, why are we even doing this? Why are we introducing this concept? It's because chemistry happens on an atom to atom basis. Or in other words, I have to know how many atoms I have. Okay? So since just kind of like what we were looking up over here. We're counting atoms, okay? So chemistry happens on an atom-to-atom basis. So I must know how many atoms I have. And then we can start to predict how are these atoms going to react, or how many other atoms do I need. So if we go back and look at this reaction we have up here, okay, so this happens, I need 2 of these hydrogen H2s per every 1 oxygen. Okay, so if I had 2 oxygen, 2 O2s, say I had another O2 up here, mine's not going to quite look as good. I'll just do this. Say another oxygen molecule up here, well, I would need 2 more additional H molecules, right, to keep the ratio the same, to keep this 2-to-1 ratio. And then I'd produce 2 more water molecules. So when a reaction happens, this is really what's going on. You know, individual ones of these are pairing up with this guy to produce 2 waters. But when we see it again, we're seeing it on such a massive scale. So a mole is going to allow us to come in and look at what type of scale that is. Okay, how large of a scale is that really happening on? So a mole is 6.022 times 10 to the 23rd items.